Hello, calculus class. So this is me attempting to show you, without me actually being in class, the end of that example that we did not quite get finished yesterday, Thursday, February 5th. So this is a very crude video just done on my iPad. It goes out of focus sometimes. I really hope it works out though. So here we go. Recapping real quick. We started with this equation yesterday. Let's review what we found. We found that our domain is all real numbers except 0. So x cannot be 0 in this case. We found that there is a vertical asymptote at x equals 0. We did our first derivative test. We found our critical numbers at positive and negative 3. So when we did our little number line here, we know that something's happening at negative 3, something weird, an asymptote, is happening at 0, and again at positive 3, something is happening. We tested some points in each of these intervals, and we found that the first derivative was negative, positive, positive, negative. So we found that we had a minimum value at negative 3 and a positive negative maximum value at positive 3. So that tells us a little bit about our extrema. Then we continued. We started talking about our vertical tangent lines, but we knew that that only happened if the first derivative was undefined, and it's never undefined, therefore we don't have any in this case. The only time that would happen is when x is 0, but we know that's not in the domain, so that doesn't really affect us here. Then we went into our second derivative information, and we found when we solved the first derivative, second derivative, we got the x values that are potential inflection points are the positive and negative square root of 18, which was approximately positive and negative 4.24, etc. So we're going to do our number line again, but this time with our second derivative. So we know something's happening at negative 4.24, something's happening at 0, and something's happening at positive 4.24. Again, 0 is our asymptote. When we tested the second derivative at each of these intervals, we found that we had a negative second derivative, a positive second derivative, a negative second derivative, and a positive second derivative, meaning we are concave down, up, down, up. There we go. Moving on, we talked about our horizontal asymptotes. And we knew that at very, very large values of x, really our equation could be simplified to x squared over x cubed, which is really just 1 over x. So we found the limit as x approaches positive infinity of this kind of modified function is just 1 over infinity, which is 0. And the limit of this sort of modified function as x approaches negative infinity is 1 over negative infinity, which is still 0. So stuff's happening in the middle of this function at near the asymptote, but at the very, very far reaches, it's just going to 0, so it's going to flatten off. Last thing we did is we talked about the intercepts. We talked about in class yesterday that there is no y-intercept because of the asymptote. Asymptote, therefore there is no y-intercept. The x-intercept, though, where the whole original function is equal to 0. And that happens when x squared minus 3, the numerator, is equal to 0. So we have x-intercepts at positive and negative root 3, 0, which is positive and negative 1.73, etc., 0. Okay. So let's go from there. those are all the tests we needed to do, but now we want to put it all together. This is where we kind of got rushed at the end of class there. So what I'm going to do is attempt to slide this up here. Yep, there we go. Okay, things we know. We know stuff is happening at a couple specific x values, and we're going to find out what those y values are that match with it. We know that something is happening way over at negative 4.24, etc. That's the square root of 18. We know something's happening at negative 3. Something's happening at negative 1.73, etc. Something's happening at 0. Something's happening at positive 1.73, positive 3, and positive 4.24, etc. We know that 4.24 and positive 4.24, those are our inflection points. Negative 3 and 3 are our extreme values. Positive and negative 1.73 are our x-intercepts, and 0 we know is an asymptote. So what we're going to do is take our original function. We have f of x equals x squared minus 3 over x cubed. And our goal is to figure out what are the y values that go along with any of these guys. And this is where in class I just told you what they were, and I got two of them mixed up in my head. So what we would do is we would take negative 4.24, plug it in for these guys. Wherever we see x, plug it in. And what we should find is that we get negative 0.196, etc. For negative 3, we get negative 0.2 repeating. For negative 1.730, we know, because we forced it to be this way, we're going to get 0. At x is 0, we get undefined. And then these kind of all just repeat a little bit. We know we have another x-intercept at 1.73. At 3, we're going to be at positive 0.2 repeating. Again, if we just took 3 and plugged it in here. And at 4.24, another inflection point, we're going to have a point at 0.196, positive this time. So these are our important numbers. And I'm also going to take a number line here and kind of superimpose our first and second derivative tests on this. So we know a couple things. I'm going to put on my inflection points and my extreme value points on this same number line. So we have 0, positive 3, positive 4.24, negative 3, negative 4.24. There we go. So looking back at my first derivative test over here, on the far side of negative 3, I see that I have a decreasing function. So on the far side of negative 3, I know I have a decreasing function, a decreasing function. From negative 3 to 0, I have an increasing function. And from 0 to positive 3, I had an increasing function as well. Go back over. On the far side of 3, then, I have a decreasing function. So over here, I have a decreasing function, a decreasing function. Okay, so that's what my first derivative tells me. Now, I'm going to have to do some big sliding here. We have the second derivative. Second derivative comes from this guy. We see on the far side of negative 4.2, I have a concave down function. So back up here. Far side of negative 4.2, I have a concave down function. Over here, I see from negative 4.24 over to 0, it's concave up the whole time. So for both of these intervals, I'm concave up. Concave up. Concave up. Okay. Going from 0 to positive 4.24, I am concave down the whole time. So that covers both of these intervals. I'm concave down, concave down. Okay. And then finally, on the far side of 4.24, I am concave up the whole time. So we have concave up. There we go. So this, in combination with all of these points, is going to be enough information for me to get a very good sketch of this graph. So I am going to attempt to put it right here. Hopefully that'll work out. Like I mentioned in class, I'm going to kind of stretch it very, very far because we see our y values here are very, very small. So I want to show this on my graph. So I'm going to go out to 5, either direction. 1, 2, 3, 4, 5. Out to 5 the other direction. -1, -2, -3, -4, -5. And I'm going to put a big tick mark up here at just 1/2. And over here at negative just 1/2. Okay. Just because my y values are so small. Okay. So now I'm going to plot these key points on my graph and then use this information to connect all of them. So I know when I'm curving up, when I'm curving down. Should I be increasing? Should I be decreasing? What's going on here? So here we go. Plotting each of these points. And this doesn't have to be exact. We see they're awkward decimals. So we have -4.24 roughly there. I'm going down. If this is -0.5, we have 1, 2, 3, 4. So I am roughly right here. -3, -0.2. I am roughly right here. 1.730. At 0, I have my asymptotes. I'm going to use a fun color to show that. Asymptote. Okay, so that's my red line, you shall not pass line. 1.73 at 0. 3.2, so we're at 1, 2, 3, 4. 0.2 is up here. And at 4.24, up slightly lower, there we go. So I believe I had these two numbers mixed up in class yesterday, so that's why it didn't quite work out. So I have these points. Now I'm going to use this information down here to connect all these points. And keeping in mind too, I can use a blue marker for this one. I know some stuff is going to happen in the middle of this graph where I am focused right now. Clearly I am crossing the x-axis at some point, but I know way, way, way out here it's just going to flatten off. I have a horizontal asymptote, and way, way over here I have a horizontal asymptote again at 0. We talked about that in one of our tests. Okay, so now, here we go, connecting the dots. From -infinity all the way up to -4.24. I am decreasing and I am concave down. That makes some sense. Way, way, way out here, it flattens off at 0 and it is concave down to this point. Decreasing, concave down. Then I go from 4.24 up to -3. I am still decreasing ever so slightly, but now I'm concave up. So I see it's going to do something more like that. Ever so slightly concave up. From 3 to 1.73 is roughly in here, 1.73 is roughly in there. I am increasing and concave up all the way up to my asymptote. Increasing, concave up, there we go. Hitting the x-intercept along the way. Flipping over the asymptote now, I have my asymptote right here at 0. All the way from the asymptote up to +3. I am increasing, but I'm concave down. So I'm starting way down here, increasing, concave down, there we go. From 3 to 4.24, I am decreasing, concave down still. So I'm going to do something like that, ever so slightly decreasing, concave down. And last, beyond 4.24, I am decreasing, but now I'm concave up. So I'm going to do something like this. So ever so slightly concave up, and I go all the way out to infinity, flattening off at 0. And that is my function. I have tested all of the things I needed to test. I know the domain is all the numbers except for 0 at my asymptote. I see that my x-intercepts are there and there. Like I suspected, I have a maximum value at 3, a minimum value at -3. The concavity is changing. I have an inflection point right here at negative 4.24, concave down to concave up. Another inflection point over here at positive 4.24, concave down to concave up. There we go. And that'll do it. So that's all I need. That's as much as I need. A lot of information in that graph, but we used all of our tests to figure out what does this equation look like. So there we go. Hopefully this helps. I will put this up on the website if I can. I hope it's small-ish enough, maybe. So if you need to look at this again, you certainly can. That'll do it. Happy mathing!